Okay, here's part 2 of the algebra review. We'll talk about linear equations, inequalities, and arithmetic sequences. So here's some terms we should know when we're dealing with equations. We should know what slope-intercept form means. And here we have it. We have y equals mx plus b. M is the slope, and b is the y-intercept. So that's where the line crosses, and this is the slope. This is the rise over run. So for example, if we had this, and this is in slope-intercept form, we know the slope is 2, and since it's positive, we know that this line is going from left to right, it's going up. And so the slope is actually 2 over 1, so it's going up 2 over 1 each time. So it's going up 2 over 1, up 2 over 1, up 2 over 1, and so forth. Now, if we made a rough graph right here, we know that this line is going to cross at the 5. And then from this 5, we know it's going up 2 over 1 each time. So that's slope-intercept form. Okay, and we also have point-slope form, which we'll talk about in a minute. Basically, you have 2 y's here and 2 x's and a slope. And we'll talk about that in a minute. So let's look if we have a graph. So let's look at this. We have a graph here, and you might not be able to see this. So we're just looking for points on the graph. And you want points that go right into these lines here. So this is you want integers. You don't want to really deal with anything that's not an integer. So I just circled in these 2 points, and now we can try to find our equation. You just need 2 points when you're using the slope-intercept form. So what we have here, we have 0, 6 is 1 point, and we have 3, negative 4. So that's 0, 6, and we have 3, negative 4. 1, 2, 3, negative 4. So here's our 2 points, 0, 6, and 3, negative 4. And we can find the slope. And the slope is 10 over negative 3. So how do I do that? Well, we can use this formula here, the change of y over the change of x. Just something fancy here. It's the rise over the run. Right? And so we're using the y over the x. So what we have is we have a y. We have 6 minus negative 4. And then if we're using that 6, we have to use that 0. And we have 0 minus 3. And so keep change, change. We're going to have 10 over negative 3. So that is the slope. So we know it's a negative slope. So the line should be going down from left to right. And if you see this from left to right, it's going down. It's negative. So we know what our slope is. It's 10, negative 3. So let's say we want to find the equation. Here's our in slope-intercept form. We already know the slope, so y is going to equal 10 over negative 3, or negative 10 thirds, x plus b. And we already know what b is just by looking at the graph. It's crossing at 6. So again, we have this, negative 10 over 3x plus 6. There's the equation. We just finished the equation. So let's see, how do we do this same equation in point-slope form? So again, I'll write point-slope form up here. It's y minus y1, and it equals, going to be the slope, x minus x1. Just basically we're using 2 y's and 2 x's. So we know the slope already. Remember the slope is, so we can write it again up here, y minus y1. It equals the slope of negative 10 thirds. Then we have x minus x1. So now we want to know, we want to keep that y. We want to know any 2 y's we want to use. If we go back, we have a y here, and we have a y here. So we can use any point on the line. We can just use one point. We can use this point, or we can use that point. So we'll just use this point. It seems easier, but whatever point you choose. So we're using 0, 6. 6 is the y. So we're saying y minus 6 equals negative 10 over 3, and then x minus 0. Okay. So now we could distribute this, and we have y minus 6 equals negative 10 third x, and anything times 0 is just 0, so we don't have to put anything there. Okay, now we want to get y alone, so we're going to add the 6 on both sides, and we're going to say y equals negative 10^3 x plus 6. And that's the same equation we got before. So in this way, we did the slope-intercept form, and in here we did the point-slope form. There's also standard form. Most of the time you'll see stuff in standard forms. For example, if I had something, let's say I had 4x plus 2y equals 12. That's in standard form. If I wanted to put it in slope-intercept form, I need to get the y alone. So I'm going to minus the 4x on both sides. Now I have 2y equals 12 minus 4x. Or you can have it minus 4x plus 12. If I divide the 2 on both sides, here we have y equals 6 minus 2x. Or y equals negative 2x plus 6. So this is in slope-intercept form, and this is in standard form. You might see that sometime. Okay, so let's see if we can answer this question. Write an equation of the line parallel to a line going through this point. Okay, and to do a question like this, you need to know what the previous equation was. So let's look at this equation, y equals negative 2x plus 6. Now remember, parallel lines, very important, parallel lines have the same slope. So we already know, if we write this here, y equals negative 2x plus b. They have the same slope. Keep that in mind. So again, it's negative 2x plus 6. We want a line parallel to that. So keep this in mind. Then just plug in the 4 and the 3. So the 4 is the x. So we're going to, and the 3 is the y. So 3 is going to equal negative 2 times 4 plus b. 3 is going to equal negative 8 plus b. We're trying to find b here. We're going to add the 8 on both sides. And we have 11. So 11 equals b. So now we know the equation. So if we look at this equation here, well, actually, was this equation? This equation, of course, it could be any equation, but we use this one. So what is parallel to this? Well, we're going to say y equals negative 2x plus 11. They're parallel. And again, parallel lines have the same slope. And just to remember, perpendicular lines have the opposite slope. They have the negative reciprocal slope. For example, if I had a line that was 2 of a slope, the negative reciprocal would be 1/2. If I had this is for perpendicular lines. Okay, let's look at arithmetic sequences now. Turn this up. Let's say we want to write an equation for the nth term of the arithmetic sequence. So an arithmetic sequence just is a sequence of numbers. So let's look at this one, for example, 8, 10, 12, and 14. First thing you should know is what is the difference. They're going up by 2 each time, so the difference is 2, so keep that in mind. So we have this fancy formula, and all this is the answer for what we're trying to get. And A1 means the first term. So 8, right there, is the first term. And D is the difference, and so we know what the difference is. Difference is 2. Okay, so it says, let's go back to the equation, the question that is, it says write an equation for the nth term of the arithmetic sequence. Now we can't answer this unless we know what term we're looking for. So if we're looking for, let's say, they might say this. That means we're looking for the 25th term. Okay, so go here. That's the first term, the second term, the third term, the fourth term. Okay, we know it's going up by 2 each time, so we know that the fifth term would be 16. So we can keep going that way until we find the 25th term, or we can follow this formula. Okay, so let's plug in some things. What do we know? Well, we know the first term. We know the difference. And again, an in this case now is going to be a to the 25th term. So we have 8 as the first term. And we have the second, the difference of 2. So what we did here is we want to distribute this. And by the way, You can also have it where 2 is here. Most people like it that way anyway. Bring that over. So I distributed this and I got 8 plus 2n minus 2. Okay? And we're trying to find this term, the 25th term. Now here, 8 plus negative 2 is 6. So now we have this is 6 plus 2n. Again, we had 8, but 8 minus 2, got to combine like terms here. We're going to get 6 plus 2n. We're trying to find the 25th term, so we plug in, that's what n is, the 25th term, and we'll get this. So the the 25th term would be 56. That's an arithmetic sequence. Okay, let's look at some inequalities. So let's say you saw a graph like this, and you had to graph an inequality. Bring that over. So inequalities and linear equations, basically the same thing, but we're going to be using inequality signs instead of equal signs. If you see a dotted line, you're either going to see a dotted line or a solid line. If you see a solid line, you would use these two symbols. So this is a solid line. And if you see a dotted line, you'll see these two symbols. So all a dotted line means is we're not including what's ever on the line. If we had a solid line, it means we're including everything on the solid line. Now for this inequality, this is the shaded area. Put arrows here in the shaded area. That means that this is the solution. The solid area is the solution. Okay? So now you want to know if the solution is above or below the line. Well, just take any point on the line, and if you go up, are you in the shaded area or not? So, well, here's a point right here on the line. If you go up, you're in the non-shaded area. So it's below the line. Okay, so you're either going to be above the line or below the line. And we're going to have an equation. So here's a related equation that's not an inequality. It'll be y equals mx plus b. But in an inequality now, we're going to have y, and we're not using these because it's a dotted line. So if it's below the line, that means y is less. The answer is less. If it was above the line, so this is what below means, where y is less. If you saw something like this, that means it's above. Y would be more. So you should rewind the tape if you don't understand that. Again, it's below the line, so y is going to be less. So we have y is going to be not equal, but less than mx plus b. I'll write that over. Y is going to be less than mx plus b. Now, let's try to find what they are. Same way we did linear equations. We need to find some points on this line. Okay, and we know it's not include. So look for something that's right on. Here's a point right there. It's right on the line. And let's see what else we have. We have one right here. So we have 2, 5. Write this over here. Here's our points. 2, 5. And we have 1, 2. Those are our points. So we can use point-slope formula, slope-intercept formula. We don't have the slope, so let's get the slope. Okay. Again, we're using 2, 5, and 1, 2. So we can say 5 minus 2, that's the y, that's the rise. And the run, if we're using 5, is 2 minus 1. So we're going to have 3 over 1, so the slope is 3. So we're saying that y, and it's below the line. Remember, it's below the line. We're saying y is, since it's below, is going to be less than 3x plus b. That's what we have. Now, let's try to find what b is. Well, we can plug in any 2 points we want. right? Let's say 1 and 2. 1 and 2 looks good. So if we're saying if y is 2, 2 has to be less than 3 times 1 plus b. So that's 3. So 2 has to be less than 3 plus b minus the 3 on both sides, and you get negative 1. So our answer to this equation then would be y is less than, we're going to say 3x minus 1. That's the equation, the linear inequality.